for a specific purpose only. The least number, that is one, does not one denotes the nearest to topmost layer to the user, and the highest number denotes the bottommost layers only. If the architectural layer entities are one, web-based user interface as presentation layer, two, web services business layer, a data access layer, and a file database. Uh, Hello, sir. Right? If the architecture layer entities are one based, one web-based user interface as presentation layer. Second one is the web services. Third one is the business layer. Fourth one is the data access layer, and fifth one is the database. The request data moves from the presentation layer to the web service to business layer to data access layer to database. When the user performs, an action on the application, and the response move in the opposite direction. Okay. Okay. Suppose if the application people will send a data, okay, that will be transferred from the layer 1 to layer 2, layer 2 to layer 3, layer 3 to layer 4, layer 4 to layer 5. That is the database. Okay. If one application one user sends a request to that data for the database, the database gives the reverse response for this opposite directions also. Okay, these are the things happened in this one. Okay, I want to stop here. From Okay, we will discuss the remaining things in the next class. Method can be generalized to convex programming based on a self concordant barrier function used to encode the convex set. Any convex optimization problem can be transformed into minimizing a linear function over a convex set by converting to the epigraph form. A special class of such barriers that can be used to encode any convex set, if they guarantee that the number of iterations of the algorithm is bounded by a polynomial in the dimension and accuracy of the solution. Car markers breakthrough revitalized revitalized the study of interior point methods and barrier problems, showing that it was possible to create an algorithm for linear programming characterized by polynomial complexity, and moreover that was competitive with the simplex method. Already, the Chance ellipsoid method was a polynomial time algorithm. However, it was too slow to be of a practical interest. The class of primal dual path following interior point methods is considered the most successful. Okay, Mahendra's predictor and character algorithm provides the basis for most implementations of this class of methods. Primal dual interior point method for nonlinear optimization. The primal dual method idea is easy to demonstrate for constrained non-linear optimization. For simplicity, considered the all inequality versions of a non-linear optimization problem. Minimum of f of x subject to ci of x greater than equal to 0 for every I equal to 1, 2, so on m, comma x belongs to R power n. Okay, f is a function defined from R power n to R, comma ci is defined from R power n to R only. The logarithmic barrier function associated with the above equation is b of x comma mu equal to f of x minus mu into sigma I equal to 1 to m log of ci of x only. Here mu is a small positive scalar, sometimes called the barrier parameter. As mu converges to 0, the minimum of b of x comma mu should converge to a solution of equation 1 only. The barrier function gradients is g equal to g minus mu sigma equal to 1 to n 1 by c of x in delta ci of x only, where g is the gradient of the original function f of x. Okay, next advanced algorithms are there. Uh, Advanced number theory algorithms. Advanced number theory algorithms. All four-digit palindromic numbers are divisible by 11. All four-digit palindromic numbers are divisible by 11. Right. If we repeat a three-digit number twice to form a six-digit number, the result will be divisible by 7, 11, 13, and dividing by all three will give our original three-digit number also. A number of form 2n has exactly n plus 1 divisors. Okay, for example, 4 has 3 divisors like 1, 2, and 4. To calculate sum of factors of a number, you can find the number of prime factors and their exponents. Let P1, P2, and so on Pk be prime factors of n. Let A1, A2, so on Ak be the highest powers of P1, P2, so on Pk respectively. That divide n. That is, we can write n as n equal to P1 A1 into P2 A2 and so on Pk Ak. A sum of divisors 1 plus P1 plus so on P1 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 to P1 A1 into 1 plus P2 plus P double to P2 A2 and so on 1 plus Pk into Pk2 so on Pk Ak. We can notice that individual terms of above formula are geometric progression. We can rewrite the formula as like this one. P1 A1 plus 1 minus 1. P1 minus 1. Okay, next into P2 A2 plus 1 minus 1 into P2 minus 1 star and so on Pk Ak plus 1 minus 1 divided by Pk only. For a product of n numbers, if we have to subtract a constant k such that the product gets its maximum value, then subtract it from a largest value such that largest value k is greater than 0 only. If we have to subtract a constant k such that the product gets its minimum value, then subtract it from the smallest value, where smallest value k should be greater than 0 only. Gold-Bitch's conjecture. Every even integer greater than 2 can be expressed as the sum of two prime numbers. A perfect numbers are Right here, perfect numbers are those numbers which are equal to the sum of their proper divisors. For example, consider the six. The factors are one, two, three. We add them, the factors it will get. We will get the number six. Okay, right. Natural numbers are those numbers that cannot form a palindrome when repeatedly reversed and added to itself. For example, 47 is not a Lyral numbers as 47 plus 74. It gives the 121. Okay, it forms a palindrome number. 47 plus 74 forms a palindrome number. Right. Lemoine's conjecture. Any odd integer greater than 5 can be expressed as a sum of an odd prime and an even semi-prime. A semi-prime number is a product of two prime numbers. This is called Lemoine's conjecture. Fermat's last theorem. According to the theorem, no three positive integers a, b, c satisfy equation a power n plus b power n equal to c power n for any integer value of n greater than 2. For n equal to 1 and n equal to 2, the equation has infinitely many solutions. Right. Recent trends in problem solving using searching and sorting techniques in data structures. Yeah, coming to the searching. Okay, searching is the algorithmic process of finding a particular item in a collection of items. A search typically answers either true or false as to whether the item is present. It returns out that there are many different ways to search for the item. Okay, what we are interested in here is how these algorithms work and how they compare to one another. The sequential search. When data items are stored in a collection such as a list, we say that they have a linear or sequential relationship. Each data item is stored in a position, okay, relative to others. In Python list, okay, these relative positions are in the index values of the individual items. Since these index values are ordered, it is possible for us to visit them in sequence. This process gives rise to our first searching technique, the sequential search. The figure shows how this search works. Starting at the first item in the list, we simply move from item to item, following the underlying sequential ordering until we either find what we are looking for or run out of items. If we run out of items, we have discovered that the item we were searching for was not present. The implementation for this algorithm is shown below. The function needs the list and the item we are looking for and returns a boolean value as to whether it is present. The boolean variable found is initialized to false and is assigned the value true if we discover the item in the list. Okay. Definition of sequential search of a underscore list and item. Position is equal to 0, found equal to false, while position less than length of a underscore list are not found. If a underscore list of position equal to item, found equal to true, else position equal to position plus 1, a written found. Test underscore list equal to 1, 2, 32, 8, 17, 19, 42, 13, 0. Print sequential underscore search of test underscore list comma 3. Okay, test underscore list comma 13. Okay, analysis of sequential search. To analyze such algorithms, we need to decide on a basic unit of computations. Recall that this is typically the common setup, the common step that must be repeated in order to solve the problem. For searching, it makes sense to count the number of Comparisons performed. Each comparisons may or may not discover the item we are looking for. In addition, we make another assumption here. Case, best case, worst case, and average cases. Item is present. Case 1. Okay, best case అంటే ఫస్ట్ దగ్గర ఉంటే బెస్ట్ కేస్ అంటాం. ఐటమ్ ఫౌండ్. ఓకే, nth పొజిషన్లో దొరికితే వర్స్ట్ కేస్ అంటాం. n/2 పొజిషన్లో దొరికితే యావరేజ్ కేస్ అంటాం. ఐటమ్ నాట్ ప్రజెంట్. ఇంకా బెస్ట్ అయినా వర్స్ట్ అయినా యావరేజ్ కేసెస్ అయినా లాస్ట్ ఐటమ్ దాకా వెళ్తేనే చెప్పగలుగుతాం. ఓకే, అది మనకి ఈ అల్గారిథం ఉన్న ఒక డిసడ్వాంటేజ్గా చెప్పుకోవచ్చు అండి. ఓకే, రైట్. Coming to the binary search. In binary search, first we need to compare our required element with the middle element. Okay, here the one drawback is that the input must be an order set only. Okay, first we need to find out the mid element. First we will compare our search element with the mid element. If both are same, then exit. If our search element is less than the mid element, then go for the search in the left subarray. If the search element is the greater than the mid element, then go for the right side of the array only. Coming to the analysis of binary search. To analyze the binary search algorithm, we need to recall that each comparison eliminates about half of the remaining items from consideration. What is the maximum number of comparisons this algorithm will require to check the entire list? If we start with n items, about n/2 items will be left after the first comparison. After the second comparison, there will be about n/4, then n/8, n/16, and so on. How many times can we split the list? Table coming to the table 5.3, this helps it. How many times split? This one. Okay, right. When we split the list enough times, we end up with a list that has just one item. అంటే ఎప్పటితో మనం స్ప్లిట్ ఎనఫ్ అలా స్ప్లిట్ చేయడం ఆపుతామంటే ఒక ఎలిమెంట్ వచ్చే వరకు. ఎయిదర్ దట్ ఈస్ ద ఐటమ్ వీఆర్ లుకింగ్ ఫర్ ఆర్ ఇట్ ఈస్ నాట్. It is not. Either way, we are done. The number of comparisons necessary to get to this point is I, where n square I equal to 1. Solving for I gives us I equal to log n. The maximum number of comparisons is logarithmic with respect to the number of items in the list. Therefore, the time complexity of binary search is log n. Even though a binary search is generally better than a sequential search, it is important to note that for small values of n, the additional cost of sorting is probably noteworthy. In fact, we should always consider whether it is cost effective to take on an extra work of sorting to gain searching benefits. If we can sort once and then search many times, the cost of the sort is not so significant. However, for large list sorting, even once can be so expensive that simply performing a sequential search from the start may be best choice. So coming to the sortings, there are multiple sortings are there, bubble sortings are there, and selection sort is there, and insertion sort is there, and shell sort is there, merge sort is there, pick sort is there. Okay, those are the sorting algorithms are there. Okay. For each and every algorithm, there are different kind of approaches are there. Yeah, you need to use those algorithms. So you need to, if you want to sort some of the algorithms, it depends upon the size, it depends upon the time. We can select one of the algorithms, and it depends upon the input also. There are many algorithms are there here. Some of the sorting algorithms they mentioned here, but really in real life there are plenty of sorting algorithms are there. Right, plenty of sorting algorithms. Sortings, bubble sort. Coming to the bubble sort algorithm, the bubble sort makes multiple passes through a list. It compares adjacent items and exchanges those that are out of order on. Each pass through the list places the next largest value in its proper place. In essence, Each item bubbles up to the location where it belongs to. That figure shows the first pass of a bubble sort. The shaded items are being compared to see if they are out of order only. If there are n items in the list, there are n minus 1 pairs of items that needed to be compared on the first pass. It is important to note that once the largest value in the list is part of a pair, it will continually be moved along until the pass is complete. At the start of the second pass, the largest value is now in place. There are n minus 1 items left to the sort, meaning at that n minus 2 pairs only. Since each pass places the next largest value in place, the total number of passes necessarily will be n minus 1. After completing the n minus 1 passes, the smallest item must be in the correct position. No further passing is required for this. This is about the merge sort. The 54 and 26 is there. Exchange is needed for this one. Swap 26 and 54. Next, compare 54 and 93. Okay, there is no swapping is required for that. Next, 93 and 17. Okay, there is a swapping is required. So, swap it. Coming to the 93, 77. Here is the swapping as required. Coming to the 93 and 31. There is a swapping is required. Coming to the 93 and 44. There is a swapping is required. Swap it. 93 and 55 is there. Swapping is required. Next, 93 and 20 is there. Swapping is required. 93 is there. It means the biggest element is at the end of the position. It bubble up. The biggest element is bubble up. ఓకే. అంటే మనకి ఎవాపరేట్ అవుతాయి. బాగా కాగే నీళ్ళు ఎవాపరేట్ అదే పైకి బబుల్స్ లాగా వస్తాయి సరే. అలాగే బిగ్గెస్ట్ ఎలిమెంట్ అనేది పైకి వచ్చేస్తూ ఉంటుంది. అంటే అడ్జసెంట్ ఎలిమెంట్ కంపేర్ చేస్తూ స్వాపింగ్ చేయాలా లేదా చేసుకుంటూ వెళ్తే లాస్ట్ పొజిషన్లోకి బిగ్గెస్ట్ ఎలిమెంట్ వస్తుంది. ఇన్నిసార్లు స్వాప్ చేస్తే ఒక్క ఎలిమెంట్ సార్ట్ ఆర్డర్లోకి వచ్చింది గుర్తుపెట్టుకోండి. అది బబుల్ సార్ట్. Coming to the selection sort, okay, here there is a biggest element and the smallest element is there, largest element and the last element is there. We need to compare చేయండి 20 కన్నా ఇక్కడ చూడండి here is the selection sort is there. అని మీరు బబుల్ అప్ చేసుకుంటూ వెళ్తూ ఉంటాం ప్రతిసారి లాస్ట్ ఎలిమెంట్లోకి బిగ్గెస్ట్ ఎలిమెంట్ లాస్ట్ బటన్లోకి నెక్స్ట్ బిగ్గెస్ట్ ఎలిమెంట్ అట్లా స్వాప్ చేసుకుంటూ లార్జెస్ట్ ఎలిమెంట్ స్వాప్ చేసుకుంటూ వెళ్తారు అంటే సెలెక్ట్ చేసుకుంటూ వెళ్తాం. కమింగ్ టు ద ఇన్సర్షన్ సార్ట్ అంటే ఏం లేదండి ఇక్కడ కూడా లైక్ ఫస్ట్ బబుల్ సార్ట్ లా అనిపిస్తుంది. ఏమంటాం 54 26 కంపేర్ చేస్తే 24 26 54ని స్వాప్ చేయాలి. అలాగే నెక్స్ట్ 93 వచ్చింది. 93ని 26తోనూ 54 రెండింటితో కంపేర్ చేయాలి. కాకపోతే ఇక్కడ కంపేర్ చేసి ఎక్కడ ప్లేస్ చేయాలి అక్కడ చేస్తాం. అలాగే నెక్స్ట్ నెంబర్ 17 ఉన్న 3 ఎలిమెంట్స్తో కంపేర్ చేస్తాం. ఫస్ట్ ఎలిమెంట్తో కంపేర్ చేస్తాం. సో 17 బిఫోర్ ద 26 ఇన్సర్ట్ చేస్తాం. నెక్స్ట్ 77ని 17తో కంపేర్ చేస్తాం, 26తో చేస్తాం, 54 చేస్తాం, 93. కానీ 93 కన్నా ముందు ఉండాలి కాబట్టి 93కి ముందు ఇన్సర్ట్ చేస్తాం. ఓకే. నెక్స్ట్ 31 ఫస్ట్ ఎలిమెంట్తో చేస్తాం, నో ప్రాబ్లం. సెకండ్ ఎలిమెంట్ చేస్తాం, నో ప్రాబ్లం. థర్డ్ ఎలిమెంట్తో చేస్తాం. So in between 26 and 54, 31 will be inserted. Okay, 44. Coming to the 44, compare with 17, 26, 31, 54. The 44 is less than the 54 and greater than 31. So insert 44 in between 31 and 54. Okay, and yeah, next 44. Okay, 55. Compare 55 with 17, 26, 31, 44, and 54 and 77. Okay, this is lies between 54 and 77. So insert 54 in between the 54 and 77. That's why it is called the insertion sort. Okay, compare 20 with 17 and 26. It is an intermediate value in between 17 and 26. So insert into that value. That's why insertion sort. Coming to the shell sort. There the sublists are there here. Sublist 1, sublist 2, sublist 3 are there. 54, 17, 44, sublist 1. 26, 77, 55, one more sublist is there. 93, 31, 20 is the sublist is there. Okay, compare these three sublists. Okay, 17, 54 and 54 is there. Which is the smallest one? 17. Okay, place them into. Next to 26, 26, 26. Unfortunately, 26 is next to smallest. 93, 93, 20. 20 is the smallest. So insert that. Like that, we need to use the shell charts. Merge sort means that we need to combine the two arrays are there. Okay, from those two arrays, compare the each and every element. Appropriate swappings are needed, then combine the solution. Yeah, here the example is there for the merge sort. ఇక్కడ ఒక ఎగ్జాంపుల్ చెప్పారు 54 26 93 17 77 31 44 55 20. ఓకే, ఇక్కడ 54 26 కంపేర్ చేయండి, వాటిని ఆర్డర్లో పెట్టండి. నెక్స్ట్ టూ ఎలిమెంట్స్ని తీసుకోండి, వాటిని కంపేర్ చేసి ఆర్డర్లో పెట్టండి. నెక్స్ట్ టూ ఎలిమెంట్ తీసుకొని కంపేర్ చేయండి, ఆర్డర్లో పెట్టండి. నెక్స్ట్ టూ ఎలిమెంట్ తీసుకోండి, కంపేర్ చేయండి, ఆర్డర్లో పెట్టండి. పొరపాటున 44 సపరేట్ రాస్తారండి వీళ్ళు. యాక్చువల్గా 44 55గా చేస్తాం. చేసి వాటి ఆర్డర్లో పెట్టాలి. నెక్స్ట్ 55 20 20 ఒకటే మిగిలిపోద్ది. నెక్స్ట్ లెవెల్ అది కిందకి వచ్చేస్తుంది, సరిపోతుంది. ఇట్లా ఆర్డర్లో పెట్టుకుంటే వెళ్తూ ఉండాలి. ఓకేనా, ఇప్పుడు 2 ఎలిమెంట్ చేసాం, నెక్స్ట్ 4 ఎలిమెంట్స్ తీసుకుంటాం. ఫస్ట్ 4 వీటిని కంపేర్ చేసుకుంటే స్మాలెస్ట్ ఫస్ట్ రాస్తాం, నెక్స్ట్ హైయెస్ట్ పక్క రాస్తాం, నెక్స్ట్ హైయెస్ట్ అలా రాస్తాం. నెక్స్ట్ 4 ఎలిమెంట్స్ తీసుకుని అలా కంపేర్ చేసుకుంటూ వెళ్తూ ఉంటాం. అలా మెర్జ్ చేసుకుంటూ వెళ్తూ ఉంటాం. దట్ ఈస్ అబౌట్ ద మెర్జ్ సార్ట్. Coming to the quick sort, first element. Generally, first element is the pivot element. Next, select the element which is less than pivot and which is greater than pivot. ఓకే, అవన్నీ చూసుకుంటే వెళ్ళాలి. అది అప్ డౌన్ ఎలిమెంట్స్ అని చెప్తుంటాం. వాటికి ఒక ప్రొసీజర్ ఉంటుంది. ఆ ప్రొసీజర్ ప్రకారం వెళ్తూ ఉంటే కనుక మనం ఎలిమెంట్స్ని స్వాప్ చేసేసి యారేని సబ్ పార్ట్స్గా డివైడ్ చేస్తూ ఉంటాం. సబ్ పార్ట్స్గా డివైడ్ చేయడం జరుగుతుంది. Okay, I think this is enough for this. Now, next one is the cloud computing.
నేను చెప్పా కొరియర్ వేయాలి స్కీమ్ ఉంది వాటిలో ఒకటే అని చెప్పా.
ఎలాగుంది అది కొన్ని లాగా పడవ ఉంది కదా దీపం పెట్టాలి సాంబ్రాణి చిన్న గొప్ప ఉంది కదా కలిపి పైన చుట్టూ కొండ బ్రౌన్ బ్లాక్ ఉంది లేదు బాగా ఏదైనా ఫస్ట్ నువ్వు తీసావు చూసావు మనం పెట్టాము ఇప్పుడు పాడేసానే అదే నెంబర్ 1
అదే ఫేమస్ అది స్విట్జర్లాండ్ ఇవన్నీ ఐర్లాండ్
అదే అదే దాని అది ఆ టేస్టే వేరు
స్విట్జర్లాండ్ చాక్లెట్స్ కి ఫేమస్ కదా
అవునా
స్విస్ చాక్లెట్స్
అంతకుముందు మీ తమ్ముడు ఏ ఊరు ఇంకోటి డాన్ వాళ్ళు అనేది డబ్లిన్ నాకు కాదని అడిగి మా బాబు డబ్లిన్ అని చెప్పాను వస్తున్నారా దాంట్లో వస్తారు బుక్ చేయడం వస్తారు రూమ్ హోటల్ వాళ్ళు అడిగినట్టున్నారు నెక్స్ట్ క్లౌడ్ రిసోర్స్ వర్చువలైజేషన్ అండి దిస్ ఇస్ క్లౌడ్ కంప్యూటింగ్ coming to the virtualization. The virtualization simulates the interface to a physical object by any one of 4 means. First one is the multiplexing. Create multiple virtual objects from one instance of a physical object. For example, a processor is multiplexed among a number of processes or threads. Aggregation. Create one virtual object from multiple physical objects. For example, a number of physical disks are arranged into a RAID disk. Emulation. Construct a virtual object from a different type of physical object. For example, a physical disk emulates a random access memory. Multiplexing and emulation. Examples: virtual memory with paging multiplexes a real memory and disk, and virtual addresses emulates a real address. TCP emulates a reliable bit pipe and multiplexes a physical communication channel and a processor. Okay. There is a virtualization simulates the interface to the physical object by any one of four means. First one is the multiplexing, second one is the aggregation, third one is the emulation. The emulation means that construct a virtual object from a different type of physical objects. Okay, for example, a physical disk emulates a random access memory. Multiplexing and emulation. Examples: virtual memory with paging multiplexes real memory and a disk, and virtual address emulates a real address. TCP emulates a reliable bit pipe and multiplexes a physical communication channel and a processor. A virtualization abstracts the underlying resources and simplifies their use, isolates users from one another, okay, and supports replication, which in turn increases the elasticity of the system. Virtualization is a critical aspect of cloud computing, equally important to the providers and consumers of cloud services, and plays an important role in the system security because it allows isolation of services running on the same hardware. Okay, performance and reliability because it allows application to migrate from one platform to another platform. The development and management of services offered by a provider. Performance isolations. Virtualization has been used successfully since the late 1950s. A virtual memory based on paging was first implemented on the Atlas computer at the University of Manchester in the United Kingdom in 1959. In a cloud computing environment, a virtual memory runs on a physical hardware and exports hardware level abstractions to one or more guest operating systems. A guest OS interacts with the virtual hardware in the same way it would interact with the physical hardware, but under the watchful eye of the VMM, which traps all privileged operations and mediates the interactions of the guest OS with the hardware. For example, a VMM can control I/O operations to two virtual disks implemented as two different sets of tracks on a physical disk. New services New services can be added without the need to modify an operating system. User convenience is a necessary condition for the success of the utility computing paradigms. One of the multiple facts of user convenience is the ability to run remotely using the system software and libraries required by the application. User convenience is a major advantage of a virtual machine architecture over a traditional operating system. For example, a user of Amazon Web Services could submit an Amazon Mission image containing the application's libraries, data, and associated configuration settings. The user could choose the operating system for the application, then start, terminate, and monitor as many instances of the Amazon machine image as needed using the web service APIs and the performance monitoring and management tools provided by the Amazon Web Services. There are side effects of virtualizations, notably the performance penalty and the hardware cost. As we shall see shortly, all privileged operations of a virtual machine. ఏ ఏమన్నావా ఏ All privileged operations of a VM must be trapped and validated by the VMM, which ultimately controls system behavior. The increased overhead has a negative impact on performance. The cost of the hardware for a virtual machine is higher than the cost of a system running a traditional operating system, because the physical hardware is shared among a set of guest operating system, and it is typically configured with faster and multi-core processors, more memory, larger disk, and additional network interface faces compared with a system running a traditional operating systems. A layering and virtualization. A common approach to managing system complexity is to identify a set of layers with well-defined interfaces among them. The interfaces separate different levels of abstractions are there. చూడండి, లేయరింగ్ అండ్ వర్చువలైజేషన్. మనం మామూలుగా ఏం చేస్తామంటే వీఆర్ డివైడింగ్ సెట్ ఆఫ్ లేయర్స్. ఈజ్ టు ఐడెంటిఫై సెట్ ఆఫ్ లేయర్స్ విత్ వెల్ డిఫైన్డ్ ఇంటర్ఫేసెస్ అమాంగ్ దమ్. ఓకే, ఒక లేయర్కి ఇంకో లేయర్కి ఇంటర్ఫేసెస్ వెల్ డిఫైన్డ్గా డిఫైన్ చేసి ఉండాలి. ద ఇంటర్ఫేసెస్ సపరేట్ డిఫరెంట్ లెవెల్స్ ఆఫ్ abstractions. Layering minimizes the interactions among the subsystems and simplifies the description of the subsystems. Each subsystem is abstracted through its interface with the other subsystems. Thus, we are able to design, implement, and modify the individual subsystems independently. The instruction set architecture defines a processor set of instructions. For example, the Intel architecture is represented by x36, x8632, and x8664 instruction set for systems supporting 32-bit addressing and 64-bit addressing respectively. The hardware supports two execution modes, a privileged or kernel mode and a user mode. The instruction set consists of two sets of instructions, privileged instructions that can only be executed in kernel mode, and non-privileged instructions that can be executed in user mode. There are also sensitive instructions that can be executed in kernel and in user mode, but that behave differently. Computer systems are fairly complex. Computer systems are fairly complex, and their operation is best understood when we consider a model similar to the diagram 5.1. This one. Okay, which shows the interfaces among the software components and the hardware components. The hardware consists of one or more multi-core processors. A system interconnects a memory translation unit, the main memory, and IPO devices, including one or more networking interfaces. Applications written mostly in high-level languages, often called library modules, and are compiled into object code. Privileged privileged operations such as IBIO request cannot be executed in user mode. Instead, application and library modules. मतलब ये नहीं कर right. Computer system are fairly complex. Computer system are fairly complex, and other operations is best understood when we consider a model similar to the diagram. Uh, the hardware consists of one or more multi-core processors. A system interconnect a memory translation unit, the main memory, output devices, including one or more networking interfaces. Applications written mostly in high-level languages, often called library modules, and are compiled into object code. Privileged operations such as IBIO request cannot be executed in user mode. Okay, instead, application and library modules issues system calls, and the operating system determines whether the privileged operation depended by the application provides some security or integrity, and if executes them on behalf of the user. The binaries resulting from the translation of high-level language programs are targeted to a specific hardware architecture. The first thing is to discuss is the instruction set architecture and the boundary of the hardware and the software. The next interface is the application binary interface, which allows the ensemble consisting of the application and the library module to access the hardware. The API does not include regular system instructions. Instead, it invokes system calls. Finally, the application interface API defines the set of instructions. The hardware was designed to execute and gives the application access to the ISP. It includes high-level language library calls, which often involve system calls. A process is the abstraction for the code of an application at execution time. A thread is a lightweight process. The API is the projection of the computer system seen by the process, and the API is projection of the system from the perspective of the high-level programs. Clearly, the binary is created by a compiler for a specific ISA and a specific operating system are not portable. Such code can run on a computer with a different ISA than computers with the same ISA but different operating systems. However, it is possible to compile an high-level system for a virtual machine environment the following diagram. Code compiled content compiler is there, intermediate code, portable code is there, back ఆబ్జెక్ట్ వర్చువల్ ఇమేజ్ ఇక్కడ లోడర్ ఉంటుంది, అక్కడ కంపైలర్ ఇంటర్ప్రిటర్ ఉంటుంది. ఓకేనా, రైట్. నెక్స్ట్ మెమరీ ఇమేజ్ అవుతుంది, అక్కడ మెమరీ ఇమేజ్ ఐఎస్ఏ మెమరీ ఇమేజ్ ఐఎస్ఏ కూడా జనరేట్. ఓకే, this will be happening the dynamic translation converts blocks of the guest instructions to total code. The instruction leads to significant performance improvement as the blocks are called batch and reuse blocks. Right. Next one is the virtual mission monitors. Yeah, how to monitor the virtual mission? Virtual mission monitors. A virtual mission monitor also called a hypervisor. A virtual mission super general we call it supervisors monitor చేసేవాళ్ళు, but a virtual mission monitor చేసేవాళ్ళు ఎవరంటే hypervisor. He is the software that securely partitions the resources of a computer system into one or more virtual missions. A guest operating system is an operating system that runs under the control of a virtual mission rather than directly the hardware. The VMM runs in kernel mode, whereas a guest OS runs in the user mode. Sometimes the hardware support a third mode of execution of the guest OS. VMMs allow several operating systems to run concurrently on a single hardware platform at the same time. VMMs enforce isolation among these systems, thus enhancing security. A virtual mission controls how the guest operating system uses the hardware resources. The events occurring in one virtual mission do not affect any other virtual mission running under the same VMM. At the same time, at the VMM enables multiple services to share the same platform. The environment, the movement of server from one platform to another platform, the so-called live migrations. System modification while maintaining compatibility with the original systems only. Coming to the when a guest OS attempts to execute a privileged instruction, the virtual mission traps the operation and enforces the correctness and safety of the operation. The virtual mission guarantees the isolation of the individual virtual missions and thus ensures security and encapsulations. A major concern in cloud computing is this one. At the same time, the virtual mission monitors system performance and task corrective action to avoid performance degradation. ఓకే, ఇక్కడ ఏం చేయాలి అంటే సిస్టమ్ మనం ఏం మానిటర్ చేయాలి, సిస్టమ్ పెర్ఫార్మెన్స్ దెబ్బతిన ఉండకూడదు. వాళ్ళు ఏమైతే రీసోర్సెస్ అడిగారో వాటికి యాక్షన్ కరెక్ట్గా ఇవ్వాలి, మనం సిస్టమ్ని డిగ్రేడ్ అవ్వకుండా చూసుకోవాలి. ద విఎంఎం మే స్వాప్ అవుట్ ఏ వర్చువల్ మిషన్ టు అవాయిడ్ థ్రాష్. ఓకే, మనకు ఒక స్వాప్ చేయొచ్చు, మీకు అదే థ్రాష్ అవ్వడం కూడా ఉండడం కోసం. A VMM virtualizes the CPU and memory. For example, the VMM traps interrupts and dispatches them to the individual guest operating systems. If a guest OS disables interrupts, the VMM buffers such interrupts until the guest OS enables them. The VMM maintains a shadow page table for each guest OS and replicates any modification made by the guest OS in its own shadow page table. This shadow page table points to the actual page frame and is used by the hardware component called the memory management unit for dynamic address translations. Right, memory virtualization has important implication on performance. Virtual machines use a range of optimization techniques. For example, VMware systems avoid page duplication among different virtual machines. They maintain only one copy of shared page and use copy on write policies, whereas Xen imposes total isolation of the VM and does not allow page sharing. VMMs control the virtual memory management and decide what pages to swap out. For example, when the ESX VMware server wants to swap out pages, it uses balloon process inside the guest OS and request it to allocate more pages to itself, thus swapping out pages of some of the processes running under that virtual machine. Then it forces the balloon process to relinquish control of the free page frame. So, right, next, virtual machine. A virtual machine is an isolated environment that appears to be a whole computer but actually only has. చూడండి, వర్చువల్ మిషన్ అనేది an isolated environment that appears to be a whole computer but actually only has access to a partition of the computer resources. Each virtual machine appears to be running on a bare hardware, giving the appearance of multiple instances of the same computer. Though all are supported by a single physical system, okay, virtual machines have been around since the 1970s when IBM released the virtual machine 370 operating systems. Okay, process virtual machines, system virtual machines here. A different same ISA multi-programming binary optimizers, dynamic translator, high-level virtual machines. Same ISA, different ISA from the system virtual machine. ఇక్కడ ట్రెడిషనల్ వర్చువల్ మిషన్ ఉంటుంది, హోల్ సిస్టమ్ వర్చువల్ మిషన్గా చేయొచ్చు. ఇది హైబ్రిడ్ వర్చువల్ మిషన్, కన్సైన్డ్ వర్చువల్ మిషన్స్. ఇంకా వర్చువల్ మిషన్ మానిటర్స్ హార్డ్వేర్ అండ్ ద సాఫ్ట్వేర్ గెస్ట్ ఓఎస్ ఆల్సో. ఇవి డయాగ్రామ్స్ చెప్పారండి. We distinguish two types of virtual machine: process and system virtual machines. A process virtual machine is a virtual platform created for an individual process and destroyed once the process terminates. Okay, virtually all operating systems provide a process VM for each one of the applications running. But the more interesting process virtual machines are those that support binaries compiled on a different instruction set. A system virtual machine supports an operating system together with many user processes. When the virtual machine runs under the control of a normal OS and provides a platform independent host for a single application, we have an application virtual machine, a Java virtual machine. Application virtual machine and a Java virtual machine. Right, next. A system virtual machine provides a complete system. Each VM can run its own OS, which in turn can run multiple applications. Systems such as Linux vServer and FreeBSD jails and Solaris zones based on Linux, FreeBSD and Solaris respectively. Implement operating system level virtualization technologies. And next one is the operating system level virtualization allows a physical server to run multiple isolated operating systems instances. Subject to several constraints, the instances are known as containers, virtual private servers (VPs), or virtual environments (VEs). For example, OpenVZ requires both the host and the guest OS to the Linux distributions. These systems claim performance advantages over the system based on a virtual machine such as Zen VMware, according to that, is only a 1% to 3% performance penalty for OpenVZ compared to a standalone Linux server. OpenVZ is licensed under the GPL version 2. Recall that a virtual machine allows several virtual machines to share a system. Several organizations of the software stack are possible. Traditional VM, also called a bare metal VMM, a thin software layer that runs directly on the host machine hardware. Its main advantage is performance. Examples: VMware, ESXi servers, Zen servers, OS370, and Denali servers. Coming to the hybrid, the virtual machine shares the hardware with the existing OS, example VMware workstations. Next one is the hosted. The VM runs on top of the existing OS. The main advantage of this approach is that the VM is easier to build and install. Another advantage of the solution is that the VM could use several components of the hosts, such as the scheduler, the pager, and the iBio drivers, rather than providing its own. A price to pay for this simplicity is the increased overhead and associated performance penalty. Indeed, the input-output operations, space faults, and scheduling requests from a guest OS are not handled directly by the VM. Instead, they are passed to the host OS. Performance as well as the challenges to support complete isolation of VMs make the solution less attractive for servers in a cloud computing environment. Example: user mode Linux. A semantic gap exists between the added services and the virtual machines. As pointed out in services provided by the virtual machine, operate below the abstractions provided by the guest operating system. It is difficult to provide services that checks file system integrity without the knowledge of a disk structures. Okay, performance and security isolations. Performance isolation is a critical condition for quality of service guarantees in shared computing environments. Indeed, if the runtime behavior of an application is affected by the other applications running concurrently and thus is competing for CPU cycles, cache, main memory, and disk network access, it is rather difficult to predict the completion time. Moreover, it is equally difficult to optimize the applications. Several operating systems include Linux, RKQ, Linux, Silk support some performance isolation, but problems still exist because one has to account for all resources used and to distribute the overhead for different system activities include context switching and paging individual users, a problem of describing QoS crosstalk also. Performance security. Processor virtualization presents multiple copies of the same processor or core on multi-core systems also. Right? The code is executed directly by the hardware, whereas processor emulation presents a module of another hardware system in which instructions are emulated in software more slowly than virtualization. Yeah, right. A full virtualization and para-virtualizations. A program running under the virtual machine should exhibit a behavior essentially identical to that demonstrated when the program runs directly on an equivalent machines. The virtual machine should be in complete control of the virtualization resources. A statistically significant fraction of machine instructions must be executed without the intervention of the virtual machines. Another way to identify an architecture suitable for a virtual machine is to distinguish two classes of machine instructions: sensitive instructions, which require special precautions at execution time, and conscious instructions, which are not sensitive. In turn, sensitive instruction can be control sensitive, mode sensitive. Control sensitive, which are instructions that attempt to change either the memory allocation or the privileged mode. Mode sensitive, which are instructions whose behavior is different in the privileged mode only. An equivalent formulation of the conditions for efficient virtualization can be based on this classification of machine instructions. A VMM for a third generation computer can be constructed if the set of sensitive instructions is a subset of the privileged instructions of that machine. To handle non-virtualizable instructions, one could resort to two strategies. Binary translation. The VMM monitors the execution of guest operating systems. Non-virtualizable instructions executed by a guest operating system are replaced with other instructions. Okay, next one is the para-virtualizations. The guest operating system is modified to use only instructions that can be virtualized. Right. There are two basic approaches to processor virtualization. Full virtualization, in which each virtual machine runs on an exact copy of the actual hardware, and para-virtualization, in which each virtual machine runs on a slightly modified copy of the actual hardware. The reasons that para-virtualization is often adopted are: first one, some aspects of the hardware cannot be virtualized to improve performance. Next, to present a simpler interface. VMMs are examples of full virtualization. Gen and denial are based on para-virtualizations. Okay, full virtualization requires a virtualizable architecture. The hardware is fully exposed to the guest OS, which runs unchanged, and this ensures that this direct execution mode is efficient. On the other hand, para-virtualization is done because some architectures such as x86 are not easily virtualizable. Para-virtualization demands that the guest OS modified to run under the virtual machines. కానీ ఆ రూమ్లో కొంచెం లైట్ వేసుకుని నానా దగ్గర రాకుండా ఉంది.
కాదు ఇది దగ్గుగా వస్తుంది. ఇది ఎన్నిసార్లు నొక్కితే అన్నిసార్లు దగ్గు వస్తుంది.
ఉమ్,
మరి ఇప్పుడు అక్కడికి రాసినంత
ఉమ్.
వస్తుంది.
ఉమ్. Right here, see here, this virtualizations are there. Interfaces completed. Yeah, this one from the 11th slide. Hypervisors are there. Okay, partitions the resources of computer system into one or more virtual machines allows several operating systems to run concurrently on a single hardware platform. A virtual machine allows multiple services to share the same platform. Live migrations are there. The movement of server from one platform to another platform. System modification while maintaining backward compatibility with the original system enforces isolation among the system, the security also. A virtual machine virtualization the CPU and the memory also. CPU and memory ని virtual machine virtualize చేయడం. A VMM traps the privileged instructions executed by the guest OS and enforces the correctness and safety of the operations. Okay, traps, interrupts, and dispatches them to the individual guest operating systems. It controls the virtual memory management. Next one is the maintains a shadow page table for each guest OS and replicates any modification made by the guest OS in its own shadow page table. This shadow page table points to the actual page frame and it is used by the memory management unit for dynamic address translation. The monitors the system performance and takes corrective actions to avoid performance degradation. For example, the virtual machine may swap out a virtual machine to avoid crashing. Next one is the virtual machine isolated environments. that appears to be a whole computer but actually only has access to a portion of the computer resources. Process virtual machine, a virtual platform created for the individual process and destroyed once the process terminates. System virtual machine supports an operating system together with many user processes. Traditional virtual machine supports multiple virtual machines and runs directly on the hardware. Hybrid virtual machine shares the hardware with a host operating system and supports multiple virtual machines. Hosted virtual machine runs under a host operating system only. Traditional, hybrid, and hosted virtual machines. These are the diagrams. Performance and security isolations. The runtime behavior of an application is affected by other applications running concurrently on the same platform and competing for CPU cycles, cache, main memory, disk, and network access. Thus, it is difficult to predict the completion time. Next is the performance isolation. A critical condition for quality of service guarantees in shared computing environments. A virtual machine is much simpler and better specific systems than a traditional operating system. A Xen has approximately 60,000 lines of code. Denali has only about of 30,000 code. The security vulnerabilities of virtual machines considerably reduced as the system exposes a much smaller number of privileged functions. Computer architecture and virtualizations. Conditions for efficient virtualization. A program running under the virtual machine should exhibit a behavior essentially identical to that demonstrated when running on a equivalent machine directly. The VMM should be in complete control of the virtualized resources. A statistically significant fraction of machine instructions must be executed without the intervention of the virtual machines. Two classes of machine instructions. Sensitive. Sensitive requires special precautions at execution time. A control sensitive and mode sensitive. Coming to the control sensitive, instructions that attempt to change either the memory allocation or the privileged mode. Mode sensitive instructions whose behavior is different in privileged mode. Okay, innocuous, not sensitive matter. Full virtualization and para virtualization. Full virtualization and para virtualizations. Coming to the full virtualization, a guest OS can run unchanged under the virtual machine as it was running directly on the hardware platform only. It requires a virtualizable architecture only. Like it's like the virtual machineware, VMware. Para virtualizations are there. A guest operating system is modified to use only instructions that can be virtualized. Reasons for para virtualization is some aspects of the hardware cannot be virtualized. Okay, improved performance. Present a simpler interface. Okay, Xen and Denali are the para virtualizations OS. Full virtualization and para virtualization guest OS. Hardware abstraction layer here. Hypervisor and hardware is there. Guest OS hardware abstraction layer. Hypervisor and hardware.
నాకు భయం లేదు నీకు భయం మళ్ళీ ఎక్కడికి ఎక్కుతున్నాను చెప్పిన మళ్ళీ ఎక్కడ
Virtualization of x86 architecture. A ring deprivileging a virtual machine forces the operating system and the applications to run at a privilege level greater than 0. Ring aliasing. A guest operating system is forced to run at a privilege level other than that it was originally designed for it. Address space compressions. A virtual machine uses parts of the guest address space to store several system data structures. Non-faulting access to privileged state. Several store instructions can only be executed at privileged level 0 because they operate on data structures that control the CPU operations. They fail silently when executed at a privileged level other than 0. Guest system calls which cause transitions to from privilege level 0 must be emulated by the virtual machines only. The interrupt virtualization in response to a physical interrupt. The VMM generates a virtual interrupt and delivers it later to the target guest OS, which can mask interrupts. Virtualization of x86 architecture, access to hidden state, access to hidden state elements of the system state. Example, descriptor caches for segment registers are hidden. There is no mechanism for saving and restoring the hidden components when there is a context switch from one virtual machine to another virtual machine. Compression, paging, and segmentation protect VM virtual machine code from being overwritten by guest OS and applications. Systems running in 64-bit mode can only using paging, but paging does not distinguish between privileged levels 0 and 2, and thus guest OS must run at privileged level 3. The so-called 033 mode, privileged levels 1 2 cannot be used, thus the name compression. The task priority register is frequently used by a guest OS. The VMM must protect the access to this register and trap all attempts to access it. This can cause a significant performance degradation. A VTX, a major architectural enhancement, supports two modes of operating operations: VMX root for VMM operations, VMX non-root support a virtual machine. The virtual machine control structure include host state and guest state areas. VM entry: the processor state is loaded from the guest state of the VM scheduled to run. Then the control is transferred from VMM to the VM. VM exit saves the processor state in the guest state area of the running VM. Then it loads the processor state from the host state area. Finally, transfers control to the VMware. VTX. Okay, VMX root to VMX non-root. Okay, it's a entry point, it is exit point. VTD. VTD is a new virtualization architecture. iBio MMU virtualization gives VMs direct access to peripheral devices. VTD supports DMA address remapping, address translation for the device's DMA transfers. The interrupt remapping, isolation of device interrupts, and VM routing. iBio device assignment: the devices can be assigned by administrator to a VM. In reliability features, it reports and records DMA and interrupt errors that may otherwise corrupt from memory and impact the isolations. Isolation is there. Okay, Xen A VMM based on para-virtualization. The goal of the Cambridge group: design a VMM capable of scaling to about 100 virtual machines running standard applications and services without any modifications to the application binary interface. Linux, Minix, NetBSD, FreeBSD, NetWare, and Warzone can operate as para-virtual Gen guest OS running on x86, x86 64, Ethereum, and ARM architectures. Okay, Xen domain ensembles of address space hosting a guest OS and applications running under the guest OS runs on a virtual CPU. DOM 0 dedicated to execution of Xen control functions and privileged instructions. DOM U means that a user domain. Domain 0. Domain U. Applications make system calls using hypercalls processed by Xen. Privileged instructions issued by a guest operating system are para-virtualized and must be validated by Xen only. In Xen, management operating system applications are there. In applications, we are using guest operating systems are there. Okay. That Xen runs at privilege level 0, the guest OS at level 1, and the applications at level 3 only. The x86 architecture does not support either the tagging of TLB entries of the software managers of TLB. Thus, the address space switching when the VMM activity activates a different operating system requires a complete TLB flush. This has a negative impact on the performance. Solution: load Xen in a 64 MB segment at the top of each address space and delegate the management of hardware page tables to the guest OS with a minimal intervention from Xen. And this region is not accessible to or remappable by the guest operating system. Gen schedules individual domains using the borrowed virtual time scheduling algorithms. A guest operating system must register with Gen a descriptible table with the address of exception handler validation. Okay, DOM0 components. Gen store a DOM0 process supports a system-wide registry and naming services implemented as a hierarchical key value storage. A watch function informs listeners of changes of the key in storage they have subscribed to. Communication with the guest VMs via shared memory using domain zero privileges. Next, tool stack responsible for creating, destroying, and managing the resources and privileges of virtual machines. To create a new virtual machine, a user provides a configuration file describing memory and CPU allocation and device configurations. Tools that parses the file and writes the information in GenStore. Okay, takes advantages of DOM0 privileges to map guest memory, to load a kernel and a virtual BIOS, and to set up initial communication channels with GenStore and with virtual console when a new virtual machine is created. Abstraction for network input output. Each domain has one or more virtual network interfaces which support the functionality of a network interface card. A WIF is attached to virtual firewall router. Split drivers have a front end and the DOM-U and the back end in DOM0. The two communicate via a ring in shared memory. A ring, a circular queue of descriptors allocated by a domain and accessible within Gen. Descriptors do not contain data. The data buffers are allowed off band, off band by the guest OS. Two rings of buffer descriptors, one for packet sending and one for the packet receiving and supported. To transmit a packet, a guest operating system enqueues a buffer descriptor to the send ring. Then a Zen copies the descriptor and checks safety. Copies only the packet header, not the payload, and they execute the matching rules. Gen 2.0 optimization of virtual interface takes advantages of the capabilities of some physical NICs such as checksum offload. iBio channel rather than copying a data buffer holding a packet. Each packet is allocated in a new page and then the physical page containing the packet is remapped into the target domain. Virtual memory takes advantage of the super page and global page mapping hardware on Pentium and Pentium Pro processors. A super page entry covers 1024 pages of physical memory, and the address translation mechanism maps a set of contiguous pages to set of contiguous physical pages. This helps to reduce the number of ATLB misses. Okay, this is about the third unit of the cloud computing.